Hi, and welcome to part 8 in creating a DLX architecture simulator. In this video, we are going to implement loading and storing words of data in memory, now that we have our memory in place. And then we're also going to insert instructions in memory and execute them by sequentially going through memory. And at that point, we'll be able to implement all of our R and IType instructions, and we'll be a short step away from implementing our JType instructions. And then we'll have a functional single cycle data path simulator. So as I said last time, we implemented our memory, and today we're going to use that memory. So to start, we are going to go into and review what we did with our state handler, and we're going to make sure that we're ready to actually execute instructions, or our LoadWord and StoreWord instructions. So to start, we're going to look at what our LoadWord and what our StoreWord instructions are going to look like. So LoadWord is going to set the return register to be equal to the word in memory location rs1 plus extend immediate. And what extend does is it takes the immediate value and it sign extends it. So what that means is that if we extend 0, or if we extend 2, this is equal to 0, 1, 0 in memory because it's not negative. So then it'll just fill zeros all the way. And if we extend -1, it will be 1 and then whatever the rest of it is in 2's complement, and it will extend it to be filled with 1s at the beginning. So it basically takes the sign bit, which is 0 for positive, 1 for negative, and just fills the rest of the memory with it. And then StoreWord is the word at memory location source1 plus extend immediate is equal to RD, or what's in the destination register. So it's kind of a little backwards there, but nonetheless. So in order to get, so we have our instruction where we're going to have decode information, which is going to return the response, or the opcode, and the register information. And then we're also going to return data, which is just the instruction, the remainder of the instruction except for the non-6 bits from the instruction, which is how we'll get the immediate value for our calculation. And then what execute's going to do is it's going to call LoadWord and StoreWord, where it's going to perform this calculation, and we're going to have a word location that we will use to actually get the memory. So let's change that up here. We'll pass in a location. We'll need to store that somewhere. Yeah, we'll need a way to store that. So we'll do that after. So we'll go word. So we'll just say word location for now. Just make sure errors go away. So what we'll do next is we will take in and go to our IType instructions and our IType H, and we will include our registers, and we'll create our word, LoadWord, word, HWord, and our StoreWord. And then we'll go to our C file. We'll include our header, and then we'll create our functions. Word data, HWord reg info, and then word store, word data, HWord reg info. Now the nice thing about using the C environment, or the C program language to do this, is that our values will already be sign extended, so we don't actually have to sign extend them. So all we have to do is go to our RType, get these two values, which will be our defines for our rs1 mask and our rd mask. Didn't want to duplicate it there. And then we'll have to have another one that defines our immediate mask. So we'll push these over. So our immediate mask is going to be, if we go to DLX Sim, it's going to be our very first, or our rightmost 15 values. So we can do, so it's going to be a word. So we'll do 1, 2, 3, 4, 5, 6, 7, 8. So this will give us the 15 values all the way to the right, or 16. Yeah, it should give us 16. Oh, that'll give us 4, 4. That's what we want. Yeah, we want the 4. So then what we'll do is we will do word location equals, or let's go word rs1 equals reg info and rs1 mask, and then we'll do word immediate equals data and immediate mask, and then we'll say return rs1 plus immediate, which will give us our location and memory we want to access. And then we'll do the same thing here. And then return rs1 plus im. So we can actually combine these into one operation. Let's actually do that. Let's go word build or get memory address word hword, and let's remove StoreWord LoadWord, and we'll go here and we'll change this to delete this, and we'll call this get memory location. Is that what we called it? Or location or address? Address. So it's not actually LoadWord and StoreWord, but that's okay. We'll be fine. So we've got that now. Now we can go to our instruction handler, and we need to put LoadWord into 35. So 35 is this last one here, and we want get memory address, and then move all these over again. Just that. Okay. And then the other location will be StoreWord at 43. So 0, 5, 6, 11, 12, 17. Something's wrong here. 35, 36, 41, 42, 45. So 42, 43, 44. So it should be 44, I guess. So this is 43. So I'll do get memory address. Perfect. So now we should be able to use both of those to call the function to get the address location. And then it'll come back here, and it will return that value to return value. So we need to actually specify. Oh yes, do we here? Okay, yes. Yeah, so here we check if the return flag actually is set. So if it's not set, we don't care. But what we will need is we will need a way to tell if we have a proper memory location or not, and if we should be actually sending or writing or checking for memory values. So if we look at all of our instructions that we have implemented, actually that's not true. We will need we will need do we have extra bits in our return value? We don't. So we will need a way to tell if we actually should be accessing memory or not. Because we will be returning if it's, so we will need, actually we will need a store word and a load word. So where is our state handler? So our state handler, we have return flag. So we'll copy that. We'll put that in here. And the reason we're going to need that is to actually set on StoreWord. So we will need to put a StoreWord and a LoadWord back in. So we'll need to switch this. Let's do this one as... actually, we can set that still. And we can just change this to word, load word, word data, hword reg info, and then go word location equals. See, because what we'll need to do is we'll need to set a register info flag, but our location is going to be no, yeah, it could be a full value. It could be, so we can't do that. So what we might have to do we need a way, so let's just reset this all for now to what it was. We're going to need a way to specify whether or not we are going to be returning, so whether we need to actually store data in memory or not. So actually we can take in, actually since there's only two instructions accessing memory, what we can do is we can take in, so we can go s return value and s response. So that doesn't have the op code actually. So that doesn't actually tell us what operation we have in here. So, but what we can do is we can, what else is included in here? Oh yeah, this is opcode and the register info. So let us, actually what we can do is we can go s instruction. So we'll set the instruction in and the location. So word instruction, and then because that should be fine. Because we have only two instructions, we can go word opcode, or if instruction, let's put some more brackets in here, instruction, and so the nice thing is that our instruction is a word, and so is our response here, so we can do it the exact same way we do this, where we take this, and we go, so and opcode info mask, I believe it is. Opcode info mask, shift 16. Let's put another bracket in there. Equals. So let's set some defines up here just to make it cleaner. Define, and we'll set this one to SW opcode, which is going to be SW is 0x2b, and define LW opcode is going to be 0x23. So we can say if it equals LW opcode, then we want to load values, so we say So we'll return a word. And how do we set the return value flag? Oh yeah, so if it's not, so then if it's greater than J-code or opcode equals SW opcode, or it does not, and we want AND. So if it's not StoreWord and if it's not JType, we set the register to 1, meaning we return a value, and then word access memory, and then we can say s return value equals access memory. So when we come in, our return value will be the location. When we leave, it'll be the data to put in there. So if it's LoadWord, so word memory value equals 0, because 0 will be our default. So if it's a LoadWord, then we want memory value equals memory mem, and in here we want location. And then else if instruction and opcode info mask is greater than 16 or shift 16 equals SW opcode. And the reason we're doing is an else if is because any value could come in here and say, hey, I'm here to access memory. And we don't want to give anybody access to memory. So, then we return memory value. And here we say memory mem location equals, and we want the value in RD, which we don't actually have. So we need to actually get RD, so we can pass in hword reg info. So add that in. So access memory s reg info, and add one more word here. So this is word, and we'll need reg info, or so we'll do word rd equals 0, and then we'll say rd equals reg info, and we want rd mask half word, which is going to be I forgot this on the other thing there. Oh no, it is the last one. So okay, so it's but this is an IType, so it's actually rs2. So we want rs2 mask half word, and then we want to shift it to the right 5 bits. So let's put this in brackets so that we make sure we get it in the way we want. And then we'll have registers GPR RD, and there we go. And it'll return 0. So now let's actually make sure this works. So let's say, so to test it, let's start by building it. Make sure that it builds fine. Alright, so it succeeded. Okay, so now let's go to, and let's create a function. So we'll call this a new header file, and we'll call it file handler. Yeah, file handler .h, and I should rename that to handler, not handle, handler, and we'll include a file handler.c as well. File handler. So this is going to let us do, this is how we're going to actually implement our file I/O once we do file I/O. But for now, what we're going to use it for is writing instructions to memory and executing them so that we can actually execute it the way we're going to be doing it in the future. And then we'll include DLX Sim, and we'll need memory handler, .hk. And then we'll have a function declarations, and we'll say void write file to void write file to memory, and we'll take a no arguments, and then we'll go include file handler void write file to memory. So we can add stuff later. So now I'll go to state machine, and inside state machine.h we will include file handler, and we will call inside state machine.c. We will go, before we go run state machine, in initialize state machine. If everything works, we will go and call write file to memory. And then in here, so what we'll do is we'll start by saying memory mem0 equals, and we'll say it equals. So let's start by writing a dummy. Oh, that's not what I wanted at all. Atom. Okay. So let's start the Atom app. So we have a text editor to write in. So let's look here. So this is our logger, so we can close this. But let's create a new file. And let's see if we can quickly create the increased font size. Perfect. Okay. So we're going to start with a StoreWord, and we'll say memory location. Or actually, so we want. So let's open up. We'll need the DLX Sim.h to see how our instructions are going to be. Okay. So we want to start with a StoreWord, and I'm just going to write the write it out here above in assembly, pseudo assembly. So we'll want rs1 rd immediate value, and then we'll want LoadWord rs1 rd immediate value. So we'll start with that, and we'll see if we can actually get that to work. And we'll check our memory, check our instructions, everything, to see if it will work, or check our registers, make sure everything's working. So to start with, we need StoreWord and LoadWord. So the assembly for StoreWord is 101011, or the binary, sorry, and LoadWord is 1123111. So now the next one is our source register. So we'll say register 1. So we're going to actually need to set register 1 and set register 2. So what we'll do is we will say, so we don't have an add immediate yet. Maybe we should implement that. We need a way to actually store data in memory. We'll have to set our registers beforehand. So we'll say rs1 is going to hold the destination of our memory. So we'll go 1, 2, 3, 4, 5. And then our destination for storing. So the contents we're going to store is going to be in register 2. So 1, 2, 3, 4, 5. And then our immediate value is going to be 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So now let's copy this, paste it here, and we're going to load from register 1. Yeah, and then we're going to store it in register 3. So this is going to, so for the first one, let's paste it in there. Where's our file? Okay, so memory mem 0 equals 0b, paste, and then memory mem 1 equals, and we'll paste this one. We'll go to the beginning of this, we'll go 0b. So the 0b just specifies that we're doing it in binary. So now we'll go to statemachine.c, and before we run, so this is a dirty temporary solution, and we're going to do is we're going to go and say registers GPR. So we had 1 is going to be, so that's going to be this one here, which is where our memory is located. So we're going to set that to 5. Actually, let's go memory location 3. So the very next location, which is going to mess up, so we can't make sure we process past 3. So it's going to try reading that value as an instruction. And then we'll go registers GPR 2 is going to equal the data we want to put in there. So we'll set that to 123. And then registers, I think that's everything. Oh yeah, 3 is going to be our destination for when we read the word. Okay, so now if everything works fine, we should be able to loop through to instructions and actually store and load memory. So what we'll do is we'll put a breakpoint on line 87, or where we enter process state. We'll run our debugger and we'll see what happens. Alright, so we're in process state. Let's step into it. Perfect. We should go to fetch. Okay, let's step into that. And we're just going to walk through and make sure everything's going well. So program counter is 0. Let's take a look at memory. And our memory is, well, it doesn't tell us. Okay, so let's close that. Let's go to mem. Doesn't tell us there either. Alright, so that's how it's going to tell us what we have. So, well, let's see. What is instruction? Let's see. Instruction. So that's nothing right now. So, return instruction. We can't do that as binary. But what we can do is we can copy the value. We can go hex to binary. And we can paste it. And we can convert it, and we get let's see, 4, 8, 12, 16, 20, 24, 28, 32. Okay, so let's see, what did we write in our Atom file? So let's copy this value. Let's go to Atom. Let's paste our value here and see if we got something similar or not. So we ended up with 1 too many there, so there we go. So that matches up. Perfect. So I don't know why it gave me extra there. 1, 2, 3, 4, 5, 6, 7, 8. Well, looks like it works. Let's just keep stepping. So we return, and current stage equals decode, new PC++, and then we break. And then we return the new program counter, and Program counter is now 4. Cycle counter increments. Perfect. Oh, we didn't step in. Okay, let's make sure we step in. So that was decode. So reg info. Let's look at S. So data, register info. Okay, so I guess that doesn't really help us anything too much because we kind of missed the process. But all right, so execute. Let's step into that. And let's step into function. And it's going to no op, so that's not good. Alright, so let's stop. We're in stdio to h now, so that's too far. Let's try again. And let's see what we did wrong here. So, oh, maybe we have one too few integers in here, actually. Let's split this up. 4, 4, 4, 4, 4, 4. Okay, so we do want one too few. Okay, so we want 6. And if we go to DLX Sim, so let's stop. It's the joys of working in binary. This is why we're writing a converter, so we don't have to worry about these problems here of writing it by hand. So we have 6, and then we have 5, and then we have 5, and then we have 15. So this is 3, 3, 3, and 3. So that is 15. That is 5. Oh, this should be 16, not 15. Alright, so there we go. That's what the problem is. So he's got to add an extra 0 at the end. Okay. So, let's get rid of that one. Go there. Don't need to save it. So let's go to our file handler, add the extra 0 at the end, and now save. And now if we step through, so let's go to our, let's step in. Let's set a breakpoint at each of these and make sure that we do it right here. Alright, so now let's continue. Alright, we get our instruction. Perfect. Let's see, S instruction. So let's copy that value and let's paste that in. Oh, didn't mean to close my converter. Remove padding and convert it, and I guess the padding helps. That looks much closer to what we're actually looking for. So if we now go here and paste it there, remove our spaces, we get the exact same value. Perfect. So that's better. Okay, so now if we continue through, I don't know where we are anymore. I think we're at the end. Okay, so returning. Alright, so we return, we go through again, and now we are in decode information, where we get the, what is decode information? That's where we build the register info and get our data. Okay. So let's loop through that. So now if we go through, we are now in execute. So if we step into that, get memory address right where we want to be. So perfect. So let's see what RS1 is. And we'll see what immediate is. Oh, we want immediate. So that's 0, perfect. RS1, we want to be, oh, we actually want this shifted. We want it shifted 2 and 8 is 10. So let's stop this. Let's continue. Or start it again. And that's the other nice thing about doing this twice, is that we can, having the one function for both of them, we don't have to update it twice. So let's go through. Alright, now let's step in again. Oh, we already executed it, okay. So what's our return value? Our return value is 1. which isn't what we want, I don't think. Doesn't seem right. Let's put a breakpoint in here. So that way we can just continue until we hit it. We can actually get rid of this one now. So execute. Okay. So rs1 is some weird value. So we get 1. Right, because that's our source. That's where we want to get it from. Okay. Perfect. Okay, so that does make sense. 1 is right. Okay. So now we'll get to the moment of truth. Let's now check out memory and check out the registers. So let's see if we can. So here we are. So register 1 is 3, which is our memory location, and register 2 is 7b, which is our value. Okay, and can we access memory? Let's see if we can find memory here. Solution Explorer, go to memory handler, memory handler.h rather, go to memory, go to mem, oh, because that's a pointer. So let's print out memory mem3. So 0 CD CD CD. Okay, so that's just a random value. But now let's see how it changes. So if we step over, we'll go back to cycle counter. And now we're going to actually go to access our memory. So let's go and check it out. Oh, we skipped over access memory. But access memory didn't do what we wanted to do anyways. So let's ignore. So everything up to access memory was good. So let's start this over. And let's break on access memory. Perfect. Okay, so that's fine. So access memory, let's step in. Okay, so memory value is 0, rd equals 0. Let's print instruction, which is the same as this instruction. Okay, perfect. And can we do operations here? So instruction and opcode. Well, what's opcode info mask? We can just print that out. Instruction and 0x 1 2 3 4. Oh, we don't want opcode info mask. We want. Oh, we should actually change that. It should be in opcode mask, not opcode info mask. Yeah, we want opcode mask, not opcode info mask. Oh, that's gonna change things there. So let's stop it now. Start it up again. Okay, we're there. Perfect. We continue through. Alright, so this is a nice thing about being able to step through your code is you can check things like this. So let's see, instruction and FC 1 2 3 4 5 6 16. So that's AC. Oh, we want to shift more than 16. We want to shift 26 because we want to move the first 6 bits all the way over. Oops, that's not what I want. I don't want it there. Oh no, I do. I want it there, and I want it here. Okay, so let's change this now to shift 26. Maybe that's too far. Oh, it's doing a shifting first. Yeah, so we want 26. Okay. So yeah, perfect. So 2B, and that would be StoreWord. Okay. So let's stop this. Where's that? Yeah, stop. Let's stop. Make sure it's a live change. So now, we can skip past that. We can step into access memory. And so we're going to want to watch memory location 3. So if we step over, LWord opcode is, well, it's not going to tell me. Can I peak definition? I can. Look at that. There we go. Perfect. Love this IDE stuff. So we want SWord. So it's going to go to the next one. And we're going to step in. And we're going to print out our reg info and rs2. Well, let's try this again. Peak definition. So we'll do reg info and 03E0 shift 5, and that gives us 2. So it's going to now check value 2. And okay, so now if we have GPR 2 is 7B, so it should put 7B into memory location 3. So if we step in, memory location 3, the moment of truth, and it doesn't look like it changed it. Oh, that's because location equals 1. Because we don't want location. We want, oh, so we made a big mistake. In IType C, we don't want, we want registers GPR RS1, because that's going to return the value in RS1, not the register value, not the register. So now if we continue and we step into this, and location is now 3, so now 3 is 7B, just like we want. So if we were to print our memory now, we would see that the third value stores our memory. So now if we go back here, this is LoadWord, so we're loading from location specified in 1, so location 3, and we're going to put it into register 3. So now if we go and we go registers GPR 3, that should change to 7B once this next instruction executes. So now we go back, we go to the next stage, and we'll step in, make sure nothing happens. Great, skipped over the write back. Perfect. So now we start all over again. And it's not responding. I don't know why. I don't think the cycle counter is going. Let's look at the log file. So starting the state machine main loop, so it's just Visual Studio not responding. Okay. I don't know why these are green and yellow. I think this may be new and this is updated. Anyways, Visual Studio is not responding. Why is it not responding? I don't want to lose all this if it's going to error out. Let's try restarting the program. Hopefully it doesn't kill everything. Let's take a look. Let's cross our fingers and hope. Alright, so let's open up and see. Let's open our solution and let's see what happened. See what's been saved. Oh yes, everything should have been saved because we saved before we ran. Haha! There we go. Perfect. So, let's look at IType. It's there. Perfect. So, what we'll do is we'll go to statemachine.c and let's put a breakpoint. Actually, let's go to statehandler.h and or statehandler.c and let's put a breakpoint on access memory and let's run our debugger and we'll just stop there for now and we can remove this one and we'll continue. Alright, so let's watch registers GPR 3. So this one should, and we'll do memory mem3. Alright, so we can skip this one for now because that's just going to set it, and then we'll go through until we hit it again. Oh, there's an access violation. So where was there an access violation? What's our function? Did we maybe go too far or not put this one in the right place? So let's stop here and we'll run it again and we'll see what we get for our second instruction. So we can skip that. That's fine. That's fine. Okay, so program counter is 40. That's not right. Because 40 is a really large number. Okay, so that was not right. So how did it get to 40? Let's start over and see how we got there. So that was why it was not responding before, I'm assuming. So let's skip that. So new program counter is 0. And now new program counter is 4. So let's put a breakpoint here and see how often we hit that. Alright. Oh, so new PC changed. So now why did it change? Let's stop this. Go to, oh, did we have, there was an error I had in the past. Program counter plus equals. No, that's not it. Oh, yes, I see what's going on. So what we're doing is in state handler, we are adding it to the new value. So instead of adding it, we should say it is the new value. So just set it to the new value. Because what we're doing is every time we come back, we're incrementing it by the previous value. So it'll be 4, it'll be 0, it'll get incremented to 4, and then it'll say 0 equals 4, or program counter equals 0 plus 4. And the next time, it'll say, okay, so new program counter equals 4, and we'll return that, and we'll add 4 to the previous 4, so it goes to 8. So that's why we just want to set it, because we're handling the increment here. We want to handle the increment once, not twice. So now, how does fetch work? Oh, we only want to increment it by 1. So we can actually do plus plus. So the reason that we're incrementing it by 4 was because it's actually 4 bytes of memory. But because we're not operating on a per byte level, we're operating on a per word level. So if it was per byte, we would want to do 4. But because it's per word, we only want to increment by 1. So that's the other reason it wouldn't have worked. So now, memory is 7B, like we want it to be. So now PC equals 1, So our instruction should change, and it does. Okay, perfect. So now if we continue to, let's go to execute. So we'll continue, we'll step into execute. Execute is now, we'll step into the execute actually. So we're in here like we want to be. Perfect. So we'll go through, and we'll go through, and we'll go through, and return. And now next time we go in, we will have access memory. Perfect. So let's step into that. Now, what we're going to be doing is we're going to be reading from memory and assigning that to the memory value, and then going into right back and inserting it into the register. So let's make sure that happens. We should step in. Perfect. So memory value, let's print that out. Memory value is 0. So now let's step over this, and it's 7b. Perfect. Look at that. So now we have a return value. And now if we go over, oh, I stepped over it. And it didn't work. So we want to find out why it didn't work. So let's go to state handler. So everything worked up into here. So let us loop through, hit continue, so we can turn that off, turn that one off, turn that one off. So continue. So here we are. Okay. So register info. We can actually put this here. So actually, let's go and peek the definition, and we can go and check the value. So reg info and 0x001f. So that's 0. Okay, so that's what we don't want. Because, and the reason it's 0 is because we have because we don't actually want to use the destination, we want to use the source as the destination. So what we need to do is inside of this, so we can close this peek here, where we set destination, actually here, so in LoadWord, what we want to do is we want to say rd equals reg info and rs2 mask half word shift 5, and then, well, actually we need a way to return this value. So what we should do is we should actually go in here and so for these ones, if we have a return type, so we should actually put these into here, because what we're going to do is we're going to set them up here as well. Actually, this should go at the top, otherwise it's going to cause everything to be an error. So set registers to be 1, and then shift to 5, and then do all this. And we'll copy this, and we'll paste it here, and delete that. And then what we'll do is we'll just tab all this over, and put our braces in place. So put one here, and then put one there. Okay, and what we'll do here is we will say that what we want to do is so this gets us the value in rs2, which is actually the destination, and we want to duplicate that here. So we should be able to put rs2 So yeah, this is going to get us, it's basically going to put the same value in RS2 and RD. So now we have RD as the proper location here, and if we go to IType, IType.c, we can actually change this to the actual RD mask. So let's go to RType, copy their RD mask, and paste it into the exact same. Actually, no, let's leave that. That's good. That's fine. But we'll need it for here. So now if we somewhere we don't have a proper brace. Where's our bracing issue? Somewhere we have a bracing issue and I can't find it. Well, let's see what happens when we build it. Build. Okay. Oh no, why is it erroring all over the place? Oh, okay, let's see if we can figure this out here. Well, let's just try running it and see what happens, I guess. So why is that causing an issue? I don't know, let's try running it. Something with location. What's going on? That's what I'd like to know. Our braces are all good. Braces there are good. Braces there are good. That's good. That's good. I don't know, why is it giving me an error of some kind? So location is some random value. Let's put a breakpoint here and see what happens. Let's step in. Reg info is coming back as 0. Oh, maybe we did something wrong here. Ah, yes. So there is something wrong here. We have a missing semicolon, it looks like. So something is wrong with this bracing. Okay. Now where could it be? Just can't see it for some reason. That's good. And now it's gone. Alright. So reg info is still 0. So it's still giving us errors, but why is it giving us errors? Because this can't go in here. It needs to go in there. Because we won't use this if we're in J anyways. But it's because StoreWord is the first one we do. That's why. No. Continue. Break. Stop. Okay, so before what we were doing is we were setting this value only if we didn't get our state handler. We were only executing this code if we were with a non-StoreWord or a JType, but we only want to set the return flag if it's a non-StoreWord. So we weren't even getting this register information for StoreWord, which is why we're having a problem. So now reg info will actually equal something. So now we can go through, get everything set up. So now this one should be fine. The general purpose register 3 should now equal 7b after executing this. Oh no, sorry. It'll equal that on the next instruction. So if we continue and we step through, we should be going back here. Perfect. Perfect. So then we return. And now we'll access the memory. So we access the memory. And now if we step in, we should be here. And RD is 0, which it shouldn't be. So why is that not working? Let's peek definition, reg info, and return 0x8123 equals 8,000. Perfect. So let's check that out. 8123. Convert that value, and we get 1 for return flag. So it should have returned, but it set RD. So let's check RD0. Let's go registers GPR 0. No, so it didn't even do that. Okay, so let's stop and let's come back to that. So register info is 0 for the first bit, which is fine because we shouldn't be returning on StoreWord. So we can continue. So now, if we step in, I guess we didn't need to. So 8460, okay, perfect, that's right. So now let's step over and step in, and we execute it. So what's our return value? Our return value is 3, which is the destination. Now 3 is where we want to write to. So step in, and now we should be at access memory. So step in, RD equals 0. We are in LoadWord. So location equals 3. Memory value 3. Memory value is 0. Let's print memory value. And memory value is 0 now. Okay, so we step over. Memory value is 7b. Perfect. We return memory value. Memory value goes into return value. Return value is now 3. And we say right back. And we go in. 1, 2, 3. We have return value 7b. Register info is A460. So if we step into writeback, reg info, and RD mask, so RD is 0, and that's because reg info is 460. So let's convert, and we get, oh, the problem is that we're shifting 11 when we need to shift 16 again. Alright, so now we should have the same value there twice. So let's skip. So this is for StoreWord still. So now we're on LoadWord, and RD will now equal 3. So now, if we skip over, so let's set this to is this going to equal the same thing? It might because it's a half word, it might not because it's not. Okay, so it is. Okay. So now the moment of truth is, will GPR3 equal value? It does. So there we are. We've now loaded and stored data in memory. So there's a few bugs with it, but we were able to walk through them and figure them out with Visual Studio crashing, of course. But we now have the ability to read and write instructions in memory using binary, write instructions to memory, and execute them in a sequential order. So at this point, we can now go to and add in all of our R and IType instructions. So that's what we'll do next videos. We'll add in all of our R and IType instructions. And then from there, we will be able to verify they all work, make sure they all work, and then we'll have to, from there, do file I/O, and then we can start working on making this a multi-cycle system and checking all of our hazards and stuff like that. So but that's where we'll stop it now. Until next time, happy programming.